This is week 1 of the Calculus 6. Each week I'm going to look at 6 calculus problems, 3 differentiation, 3 integration, with the aim of trying to build up those essential calculus skills that you're going to need for your A-level exams. So the 6 problems on here, if you want to pause the video, have a go at them first, and then unpause the video and the solutions will follow shortly. Okay then, we'll get started with problem number 1. So what we have here is we need to differentiate cos x to the power of 4. Now it may help to reimagine this problem as cos x in a bracket to the power of 4. Remember, that's what that essentially means. Now what we have here is a function, cos x, that's in another function, this bracket that's been taken to the power of 4. So when I have a function of a function, what I want to use here is the chain rule. So what I'm going to do is I'm going to say let u equal what's inside this bracket, this cos x, and then this would mean that I can rewrite y as u to the power of 4. So what essentially we're doing is we're breaking it down into 2 easier functions that I can differentiate. Now to execute the chain rule, what I need to work out is, firstly I need to work out du by dx. So what that means is I need to differentiate u with respect to x, so differentiate this cos x. Now when I differentiate cos x, I get minus sine x. And what then I also need to work out is dy by du, so differentiate y with respect to u. So I'm going to need to differentiate this u to the power of 4. So I'm going to multiply by the power and then take 1 off the power there for 4u cubed. Now the chain rule is as follows. To work out dy by dx, what I need to do is dy by du multiplied by du by dx. Okay, you can see there those du's would cancel, leaving you with dy by dx. So in this case, dy by dx, I do my dy by du, that's the 4u cubed, and I'm going to multiply that by du by dx, that's minus sine x. So what I then need to do is, I don't want to leave this in terms of u, I want to leave this all in terms of x. Now just go back to that original substitution, that u was cos x, and then just simply multiply this all together. So I'm going to have minus 4 u cubed, but u is cosine, so that's cos cubed, and then times by that sine x. So just multiplying it all together there. Now I've kind of gone through this the sort of formal way using the chain rule. As you get quicker and you do more practice with this, you will probably just go, oh, well, I just multiplied by the 4, I multiplied by the derivative of the bracket, which is minus sine x, and I take the power of that bracket down by 1. So as you do get quicker, you will, do this most likely quicker than what I've done there, but just showing you the full process of what we would do. So the next problem, question 2 here, is we are going to differentiate y equals x natural log of x. What we have here is a function times a function. So my first function, I'm going to call this u, is x, and my second function, I'm going to call this v, is natural log of x. So when we have a function times a function, I can't just differentiate them separately and then multiply them together. If I've got a function times a function, I need to use the product rule. Okay, the thing you'll learn in this series is the key is, you need to be able to identify when you need to use particular rules. It's all well and good when you do a lesson on product rule, you know what you have to use. The key here is to just identify when do I actually need to use it for the question. So we've got function times function, we're going to use product rule. So I find u, so u is going to be x, v is going to be natural log of x. Then what I need to do is differentiate both of these. So I need to find du by dx, which is going to be 1. Okay, differentiate x, it's just going to go to 1. And then dv by dx, well, if I differentiate natural log of x, that just goes to 1 over x. Okay, that is a result that is not in the formula book. You need to learn that. So dy by dx, what I need to do is I need to take my first function, u, and I'm going to multiply that by the second function differentiated. So I'm going to do u times dv by dx. That would be x times 1 over x. And then I do v, my second function, times the derivative of the first one. So that's 1 du by dx times by v. Okay, and I add this on to the previous result. So I do 1 times natural log of x. Okay, don't really need to show the 1, but just showing you how it's all working there. Okay, so the product rule is something you don't get given in the formula book, unlike quotient rule, which you do get given in the formula book. Okay, this result for product rule is one that you need to remember. Then what I'm just going to do at the end here is just simplify these. So x times 1 over x, well, that just goes to 1 and 1 times natural log of x. That's just going to be natural log of x. So that is problem number 2 done. Let's look at our final differentiation problem, question 3 here. And we've got this function here made up of x's and y's, and I need to find dy by dx. So what in the previous 2 problems, it was y equals some function of x. So I just went ahead and differentiated the right hand side with respect to x, and I found my solution. But here, y is not the subject of this equation. So what I don't want to do is rearrange this to get y as the subject. That's going to be a bit too much work to do. It's not impossible here, but you're going to get something that's harder to differentiate as a result. So what I'm going to do instead is I'm going to use implicit differentiation. So implicit differentiation is when it's either not possible or it's going to be too complicated to make y the subject and just have all x's as your only variable on the other side, or alternatively you can't make x the subject and have all y's on the other side. What we want to do in those situations where we can't do that is we need to use implicit differentiation. So this is how it works. I go through each term, and if it's a function of x, I just differentiate it as normal. But if it's a function of y, I'm going to differentiate it with respect to y, but to compensate for that, I'll then multiply it by dy by dx. So I still actually am going through differentiating all the terms with respect to x, but I'm using a little trick really, that if I differentiate it with respect to y, as long as I times it by dy by dx, that is going to be okay. So this is how it works. So the first term is a 2x. If I differentiate that, I just get 2. Okay, that was an x, so I just differentiate that as normal. Then I differentiate minus 3y. So I'm going to differentiate this with respect to y. So if you differentiate 3y with respect to y, you're going to get minus 3. But because this is a y, I need to times it then by dy by dx to compensate that I haven't actually differentiated with respect to x. I've differentiated with respect to y instead. This third term is the one that can catch a lot of students out. And a lot of people forget that actually what we've got here is a function times a function, because we're doing x times y here. So I'm going to need to use the product rule again here. And what I'm going to do is I'm going to let u be 6x, that's my first function, and v be y here. You don't actually need to let the first one be 6x, you could just let it be x, differentiate the xy, and then just multiply the result by 6. But I know a lot of people sometimes just prefer just to deal with it all in one go. So whatever you prefer is fine here. So using the product rule here, as we did in the previous problem, we need to find du by dx. So differentiate 6x, that gives you 6. And then I'm also going to find dv by dx. Now, because I'm differentiating a y here, I differentiate y with respect to y. If I differentiate y, that just gives me 1. But I've differentiated a y, so therefore I need to times it by dy by dx. So if you differentiate this y here with respect to x, the result is going to be differentiate y, you get 1, but then you need to multiply it by dy by dx. So this is just going to be dy by dx as your result. So then use the product rule as we did with the previous problem. U times dv by dx, I'm going to do that first. So my first function times the derivative of the second. So 6x times dy by dx. And then I'm going to do the second function times the derivative of the first. So that's du by dx times v. That's 6 times y. And then I've differentiated that 6xy completely there. Okay, so just to recap what we've done so far, the 2x went to a 2, the minus 3y went to a minus 3 times dy by dx, and differentiating the 6xy went to 6x times dy by dx plus 6y. We're not done there yet though, we need to differentiate our right hand side, and I've got a constant on that right hand side, and when I differentiate a constant, it's just going to go to 0. But it's a really important part of this. If we forget this, it's not going to, our equation isn't going to work correctly here when I differentiate, okay? Sometimes I see this and people just lose the whole equation aspect of this altogether, so you won't get that much further with the problem. Okay, so the problem, speaking of the problem, we were trying to find dy by dx. Okay, so I've got multiple dy by dx's here. So what I'm going to do is I'm going to group together all my dy by dx's. So I'm going to leave all the dy by dx's on this left-hand side, as so. And anything that's not got a dy by dx attached to it, that's going to get on over to the right-hand side. What this enables me to do is I can factor out the dy by dx on that left-hand side. So I can just factor out the dy by dx, and I've just got in the bracket there, I'm going to put 6x minus 3. Okay, on the right here I've still got this minus 2 minus 6y. So dy by dx, the benefit of factoring this out is I can simply now just divide both sides by 6x minus 3. So I end up with this result of minus 2 minus 6y divided by 6x minus 3. And that is one potential answer. If you don't like all these negatives on top, you could multiply through by -1. In which case you'd have multiply the top and the bottom by -1. So you'd have 2 plus 6y on the top and 3 minus 6x on the bottom. That would also be an acceptable answer. Okay, we have done all the differentiation problems. Now it's time to move on to the integration. So the first problem that we're going to look at here is integrating sine squared. Differentiating sine squared isn't too bad. Okay, it's a very similar process to what we did in question 1 when we differentiated cos to the power 4. Integrating sine squared requires a little bit more work. Okay, we can't simply just say, oh, let's just add 1 to our power and then divide by the derivative of sine. It doesn't work like that. Whenever you see sine squared or cos squared and you need to integrate it, automatically what you should be thinking of is your double angle formulae. Okay, in particular the double angle formulae for cos 2x. So from our double angle formula, I'm going to write it here at the top right hand side here. So when we've studied trigonometry, okay, so these videos are aimed at year 13s preparing for their exams, so hopefully you've all seen this by this point. What we should have learnt there is that cos 2x can be written as 1 minus 2 sine squared x. Okay, that just comes from your addition formulae that you're given in the formula book, which hopefully, again, you've studied how to derive that. If not, go back and have a look at that. And, you know, this is a result you don't get given, but it's a really important one to remember. Okay, so cos 2x is 1 minus 2 sine squared. There's different ways we can write cos 2x. However, because we're integrating sine squared, we want the one with the sine squared in. What I'm then going to do is rearrange this to make sine squared the subject. So to do that, I would just add 2 sine squared to both sides, take away cos 2x from both sides, and then divide by 2. So what I've done there is rewritten sine squared into 2 terms that are much easier to integrate. So instead of integrating sine squared, I'm going to think of this as integrating a half minus a half cos 2x. So now what I've got is 2 terms that are hopefully quite simple to integrate here. I'm going to integrate a half, so I've just got a constant. All I need to do when I integrate a constant is just simply put an x on it, if I'm integrating with respect to x, that is. And then integrating cos 2x. So when I integrate a minus cos 2x, this is going to go to a minus sign. Okay, minus cos goes to minus sine when you integrate. Unlike when you differentiate, your minus will become a plus, or your plus becomes a minus. And then also what I need to do is, because there is a 2 in front of the x, the coefficient of x is 2, I should say, we're going to not times by it like we would with differentiation, we're going to divide by it, okay, or multiply by a half. So at the front here, I'm going to have a quarter, okay, just dividing a half by 2, or multiplying a half by a half. There is one more thing we need. Can we think about what that other thing that we need is? Hopefully we all know. Let's not lose silly marks for this. We need our constant of integration here, because I have an indefinite integral, so there's no limits here. So I need to make sure I've got my plus c. Right, 2 more to go. And then we've done our first week of 6 calculus problems, and already we should feel like we're much better prepared for the calculus questions in our exam. Oh, x, natural log of x. Never seen that before. So we've already differentiated it. Now let's see if we can integrate it. So when we've got function times a function, we're differentiating, we want the product rule. When we have a function times a function and we're integrating, Now, if we're unable to simplify it or do some sort of recognition or substitution, if I've kind of exhausted all those possibilities, then it's going to be the time to use integration by parts. And that's essentially what we're going to need to use here. Okay, we've got two quite different functions here. So there's no simplifying substitutions that I can do. So I'm going to need to do some integration by parts. So how I do this is it's a little bit different from the product rule. Okay, the product rule I just call one of them U, one of them V. Doesn't really matter which way I do it. Integration by parts, you don't have a U and a V to begin with. You have a U and a dV by dx. Okay, that is the difference here. You have one of these we're going to call U, the other one we're going to call dV by dx. So, what I am going to do here is let one of these be U and the other be dV by dx. And the selection is really important here. So when we select our U, it needs to be something that I can differentiate. And when I select my dV by dx, it needs to be something that I can integrate. Now, differentiate natural log of x is going to go to 1 over x. Integrating it, well, we can do it, but it's not a result that we have in the formula book that we're expected to know off the top of our heads. Okay, maybe in a future week we'll look at how we actually integrate natural log of x. But for now, we kind of go, well, it's much easier to differentiate the natural log of x. So what I'm going to do is I'm going to say let U be the natural log of x, and we're going to let our dV by dx be the x. Okay, it's going to work so much better doing it this way round than if I had the U be the x and dV by dx be natural log of x. So if I differentiate U with respect to x, that gives me 1 over x. And dV by dx, that's going to be a half x squared. Okay, just add 1 to the power, divide by the new power. So divide by the 2, and we get this. So we're going to then use integration by parts. Now remember, integration by parts is something that you get in the formula book. So please refer to the formula book when you do this. So when we do this, the first bit of the formula is U times V. So that's going to be a half x squared natural log of x. Okay, that's my U times V. And then what I have to do in the formula is take away the result of du by dx times by V. So when you use integration by parts, you need to make sure that when you have du by dx times V, it's something that you can integrate easy when you times these together. Okay, where possible, you want to avoid having another situation where you have function times function and then have to do integration by parts again. Sometimes it's unavoidable, but if we can avoid it, we want to do that. Now, luckily, when we do this problem here, du by dx times by v, so we do 1 over x times a half x squared, you end up getting a half x. Okay, the basically just x squared divided by x just gives you an x there. So we've just got a single function of x now. It's not a function times function, which makes it a little bit easier. So the first part of this, well, there's no integration sign there, so there's no more integration to be done. So it's just going to be minus a half x squared natural log of x. Don't integrate that again or anything. And then I integrate, because I've still got the symbol there, so I still need to do some integration. Basically, keep integrating until you've got no integration signs left. So integrate a half x, add 1 to the power to make it x squared, divide by the power to make it a quarter, and then don't forget your plus c. This is an indefinite integral again. Okay, one more to go. So we've got here 3x minus 5 over 2 root x. My advice for this one is do not overcomplicate this one. This problem can just be solved with simply just techniques that you would have learned in first year. Okay? There's no actual year 13 or A2 techniques that you need to use for this problem. Whenever you have a differentiation or integration problem, always ask yourselves, can I simplify it first? That should always be your first question that you ask yourself with this, rather than, jump into product rule, integration by parts, substitution, recognition, and whatever, depending on the problem, whatever you might be thinking of doing. Always try and think, can I simplify it first? So are there some trig identities I can use? As is the case for this one, can I just do some simple indice manipulation and some division and things like that? So what we can do with this is just simply simplify this. So I got two terms in the form ax to the power of n. So basically I have some number times x to the power of some number. And then it's just the rules that you would have learned in the first year of A level of, to integrate, I'm just going to add 1 to the power and divide by the new power. So I'm just going to, when I've got this fraction here, what it means is both terms need to get divided by 2 root x. Now, remember, root x, think of that as x to the power of a half. Okay, you can rewrite this as, you can times the terms on the top by x to the minus a half if you prefer. I'm just going to do it via division, but whichever way you prefer is okay. But just be really careful with the 2, which I'll come on to in a second. So this just simply becomes, I'm just going to divide both of these terms on the top by 2 root x. So when I do this, when I do 3x divided by 2 root x, I'm going to focus on dividing the numbers first. So I'm going to do 3 divided by 2 first. So I'm just going to leave that as an improper fraction there as 3 over 2. And then in terms of the x's, I do x, essentially x to the power of 1, divided by root x, which is x to the power of a half, x to the power of 1, divided by x to the power of a half. Dividing indices take away the powers. 1 take away a half. It's just a half. So 3x divided by 2 root x is 3 over 2 x to the power of a half. And then I'm going to do minus 5 divided by 2 root x. So again, deal with the numbers first. Minus 5 divided by 2 is just going to be minus 5 over 2. And then I've got essentially x to the power of 0. And I'm dividing it by x to the power of a half. So 0 take away a half is just x to the minus a half. So no, I haven't actually integrated here yet. I've just simplified the problem so that it's ready to be integrated. Hopefully at this point, this is where it becomes a little bit easier. Now I've simplified it. All I need to do is just go through these two terms, add 1 to the power, divide by the new power. So x to the power of a half becomes x to the power of 3 over 2. And now I'm going to divide through by 3 over 2. Or, if you like, times by 2 over 3, times by the reciprocal of the new power. So when I do that, 3 over 2 divided by 3 over 2, dividing by itself, you're just going to get 1. The second term, if I raise the power by 1, minus a half will become positive a half. And if I do minus 5 over 2 divided by a half, or minus 5 over 2 times by 2, that's just going to leave me with minus 5. And then just have the plus c there at the end. The thing to just watch out for is the 2 on the bottom. Sometimes people say, okay, well, I'm dividing by root x, so it's the same as multiplying by x to the minus a half. But then they start multiplying the terms on top by a 2 as well, rather than dividing them by 2. So just watch out for that when we do this. But there you go. That is all 6 problems. I've gone through them all in detail, so if you did want a little bit more background and information on them, you can do. The idea of this is that if you want to just jump to the solutions, you can do, just to check them, but if you do want a kind of little bit more explanation on them and how they work and things to avoid, I've hopefully kind of gone into that. So let me know how you got on. Did you get all 6 right? Was there any that you're still not sure about how they work? Any types of problems you'd like to see more of in the future? Let me know. And yeah, just keep this up as regular practice and you'll be master that calculus by the time you get to your exam.